Happy morning, students. I wish you all a very happy and prosperous new year. Have you all enjoyed your holidays? Okay, fine. And this new year, first day class, today we are going to learn the new topic. Okay, that is lesson 5. The name of this lesson, do you know? Acoustics. Okay. It's a branch of physics, deals with the study of sound. Okay, and this lesson we are going to learn how the sound is produced, how the sound will be transmitted, and what about the speed of sound, what is its frequency, wavelength. Okay, and what are the factors will affect the speed of sound, and how to demonstrate the phenomena of reflection of sound, and what are the applications of sound. Are you ready to listen to the class? Okay. You all know that sound plays a major role in our day-to-day life, isn't it? We communicate with each other with the help of sound. And we are hearing a variety of sound that is produced by humans, animals and vehicles. And most of the musical instrument will produce the sound. Okay. How sound is produced and how it is propagated and how you hear the sound. For everything here we can see the answer. Okay. So this acoustics is a branch of physics. It deals with the study of production of sound and transmission of sound, reception of sound, how we can receive the sound, and how to control the effects of sound. Okay. So everything we are going to learn under this chapter acoustics. Acoustics means it's a branch of physics, deals with the study of sound. Okay. So here we can learn the production of sound, how the sound waves are transmitted or propagated, how we can receive the sound. Okay. How we can control and what are the effects of sound. Okay. First we are going to learn how the sound is produced. Sound is produced by vibration. You all know what is vibration? The to and fro motion is called a vibration. Okay. The vibrating bodies will produce the sound. Okay. Vibrating bodies will produce the sound. How the vibrating body will produce the sound? From the vibrating bodies it produce what? Certain energy. Okay. That is the sound energy. And you all know sound, it is a form of waves. Okay. It will be travel like waves. Okay. That are called as the sound waves. Okay. And you all know that if two persons are standing on the moon and if they are talking, means whether they can able to hear the sound to each other, whether they communicate with each other on the moon. No, because there is no material or medium is there to propagate the sound, because sound needs a material or medium like air, water or the solid material for the propagation. Okay. So the sound does not travel through vacuum. Always it need a material medium for its propagation. Because of this reason, the person standing on the moon, if they are communicating with each other, they cannot able to hear the sound. Okay. From this what we can understand, sound it's need a material or medium for this propagation. Okay. And sound can propagate through a gaseous medium or a liquid medium or a solid medium. Gas medium, liquid medium or a solid medium. No. Longitudinal waves. Okay, sound waves are longitudinal waves. Okay, it can travel through any medium, solids, liquid and gases. Okay, so you all know that there is two types of waves are there, transverse waves and longitudinal waves. Okay, so here sound waves, how it will be propagating in the form of longitudinal waves. Okay, sound waves are longitudinal waves. It can travel through any medium, solids, liquid and gases. Okay. Next, we can see the speed of sound. Okay, the speed of sound depends upon the properties of the medium. Okay, depending upon the medium, whether it is a solid medium or liquid medium or a gaseous medium, depending upon that, the speed of the sound will be. Okay, and sound travels through a medium so that the particles of the medium are vibrate along the direction. Okay, when the sound waves travels through a medium, the particles in the medium will be vibrating. Okay, that only first we learned. Vibrating object only will produce the sound. Okay, vibrating object will produce the sound. Okay, so when we are talking, that time what is the vibrating body is acting there? Vocal cord. Okay, that is the vibrating body is vibrating so that only we can able to produce the sound. Okay, so sound travels through a medium. How it can travels through a medium? The particles of the medium will be getting the vibration. Okay, so through this vibration, the energy will be transmitted from one point to another. Okay, so that only the sound wave can able to travel from one medium to or one particle to another particle. Okay, and we can see the displacement. Okay, the displacement of these particles, the form of longitudinal displacements, that is individual molecules from their mean position to it will be vibrating. Okay, a series of vibrations we can see in that high pressure and low pressure regions are formed. When the particles are getting the vibration, there is a high pressure region and a low pressure region. Okay, according to that, the longitudinal waves will be forming like a compression and a rarefaction. For example, here is the source of sound. Okay, so from the source of sound to the particle will be getting the vibration. Okay, so this is through this medium. So this arrow mark, this line denotes the mean position. From the mean position to the particle is getting the vibration. Okay, so here many particles will be there here. Okay, so like that the vibration will be transferred, or a vibration of the particles, it will be the energy will be moves from one particle to another. Okay, due to this vibration of the particles. Okay, the particle will not be going from one place to another, only the vibration is moving from one particle to another. Okay, so here in this region we can see the crowded lines. Okay, there is a high pressure region and here this is a low pressure region. Okay, so in this high pressure region we can say this it is called as the compression, and here it is called as the rarefaction or rarefactions. Okay, so compression and rarefaction is produced in the longitudinal waves. Okay, when the sound waves are propagating, here the vibrations of the particles takes place. Due to this vibration, low pressure region and high pressure region is formed, isn't it? So in this high pressure region, compression is formed, and this low pressure region, what is formed? Yes, rarefaction is formed. So compression and rarefaction is formed in the longitudinal waves. See here, in this compression and rarefaction we can represent like this. This line denotes the mean position. Okay, so this region denotes the what region? Compression region, and this space, okay, spatially it will be the waves are formed, no? So in between the spaces there, no? So this region is the low pressure region, and again here is the high pressure region. Okay, so high pressure region compression is formed, and the low pressure region rarefaction is formed. Here we can see the images of the longitudinal waves. Okay, so the pressure, high pressure region, what is formed? Compression is formed. Okay, and low pressure region rarefaction is formed. Okay, so in this longitudinal waves there is a wavelength. Okay, so in between the two successive compression, the distance is called as the wavelength. Okay, and in between two rarefactions, the successive two distance between the two successive compression or two successive rarefaction is called as the wavelength. Next one, we are going to learn categories of sound waves based on their frequencies. You know, frequency, what relation is there? Already we studied in the second lesson. C is equal to nu nu lambda. Okay, c is equal to nu lambda. So this nu denotes what? Frequency, isn't it? So from this we are finding this value of frequency means what we can get? Frequency nu is equal to the velocity or the speed of sound divided by the wavelength. Okay, so based on this frequency, how we can classify the sound waves? Okay, we can classify into three different types. Okay, that is listen here. The frequency range between this 20 hertz to 20,000 hertz. You all know that what is the unit of this frequency? Hertz. Okay, what's the unit of this frequency? Hertz. So the frequency range between 20 hertz to 20,000 hertz, that is 20 hertz to 20 kilohertz. This is the audible waves. Okay, this region is the audible range region. 20 hertz to 20,000 hertz. Okay, so this in between this sound frequency only we can hear. Human ear can able to hear 20 hertz to 20,000 hertz. Above this 20,000 hertz means that is called as the ultrasonic sound waves. Okay, ultrasonic waves, and below this 20 hertz is called as the infrasonic waves. Okay, so based on the frequency we can classify it into three types. Okay, and this audible waves, infrasonic waves, and ultrasonic waves. Okay, the audible range, the frequency, this region. Okay, 20 hertz to 20,000 hertz means that is the audible waves. Okay, and above 20,000 hertz means that is ultrasonic waves, and below 20 hertz means that is called as the infrasonic waves. Okay, based on the frequency, the sound waves are classified into three types: audible waves, infrasonic waves, and ultrasonic waves. What is the unit of this frequency? Hertz. The unit of the frequency is hertz. See this audible waves. Audible waves, it is produced by the vibrating bodies such as vocal cords, stretched strings, etc. And this frequency range is 20 hertz to 20 kilohertz. And this audible frequency is heard by a human ear. Okay, we can hear the sound up to this frequency region, 20 hertz to 20 kilohertz. Below 20 hertz also we cannot able to identify, and above 20 kilohertz also we cannot able to hear the sound. Okay, that is above 20 kilohertz means that is ultrasonic sound waves. Okay, and below 20 hertz infrasonic. These two sound waves we cannot able to detect. So this audible range frequency is heard by the human ear. Here you can see the picture of this vocal cord. Okay, when we are speaking, the vibrating object, that is vocal cord, will be starts to vibrating. Okay, so that only we can able to produce the sound waves. So next one is infrasonic waves. Infrasonic waves, the range of frequency is below 20 hertz. Okay, we cannot able to hear the infrasonic sound. Okay, because the frequency is below 20 hertz. Okay, so it is cannot heard by human ear. Okay, when this infrasonic waves is produced means during earthquake time. Okay, earthquake will be producing this infrasonic waves. Okay, that is below 20 hertz, and also this ocean waves and sound produced by whales. Okay, so these are the infrasonic sound waves. Okay, these are the examples. Okay, waves produced during earthquake, ocean waves, and sound produced by whales. Okay, these are the examples of the what type of waves? Infrasonic waves, that is below 20 hertz. Here we can see the sources of the infrasound. Okay, during earthquake time, it will be producing infrasonic waves. Next example, sound produced by whales. Okay, so what type of sound it is producing? Infrasonic sound waves. So next one, ultrasonic waves. So in this ultrasonic waves, the frequency greater than 20 kilohertz or 20,000 hertz means that is called as the ultrasonic waves. Okay, but we cannot able to detect these waves. Human ear cannot detect these waves. Okay, some of the creatures like mosquitoes, dogs, bats, dolphins, these and all can able to detect these waves. Okay, and also this bats will produce this ultrasonic waves. Okay, so that easily it can able to find its prey. Okay, so it will producing that ultrasonic sound waves. So it can identify, it will be help it to get a prey. Okay, to identify the prey easily. Okay, so bats will produce what type of waves? Ultrasonic waves. Here you can see the examples of this sound produced animals. Okay, what type of sound? Ultrasonic sound. Okay, what and all mosquitoes will produce this, can identify this ultrasonic waves. Okay, and dogs will produce this sound. Okay, and bats and dolphins. Okay, these are the creatures will detect this waves. Okay, and also bats will produce the ultrasonic sound waves. So what are the three different types of waves based on the frequencies? Audible waves. Next what? Audible waves. Infrasonic waves. Then what? Ultrasonic waves. Okay. Do you all know these three types of waves? Audible waves means the frequency range 20 Hz to 20 kHz. It can be produced, audible waves produced by vocal cords, stretched strings, etc. Okay. And it can be heard by the human ear. Okay. And ultrasonic waves. So the second one is what type of waves? Infrasonic waves. Infrasonic waves, frequency below 20 Hz. It cannot heard by human ear, and waves produced during earthquake. Okay, these are the examples. Ocean waves, sound produced by whales. Third one, ultrasonic waves, frequency greater than 20 kHz. Human ear cannot detect these waves. Okay, mosquitoes, dogs, bats, dolphin can able to detect these waves. Next one, we are going to learn the difference between the sound waves and light waves. Okay, the second lesson we learned about the characters of light, isn't it? So here we can see the difference between these two sound waves and light waves. Okay, the first one, sound waves. Okay, first point, here for the propagation of sound waves, it required the medium. Okay, sound does not travel through vacuum. Okay, it requires the medium. Medium is required, either air medium, water medium, or solid medium. Okay, medium is required. The light waves, the medium is not required. Even it can able to travel through vacuum also. Already we learned the properties of light, isn't it? So it does not require any medium for its propagation, but the sound waves require the medium for its propagation. And the sound waves are what type of waves? Longitudinal waves. Sound waves are longitudinal waves, and the light waves are transverse waves. Okay, these are the longitudinal waves and these are the transverse waves. Okay, and the wavelength ranges from 1.65 millimeter to 1.65 meter. Okay, wavelength ranges 1.65 millimeter to 1.65 meter. But here the range is 4 into 10 to the power minus 7 meter to 7 into 10 to the power minus 7 meter. The wavelength range is 4 into 10 to the power minus 7 meter to 7 into 10 to the power minus 7 meter for a light waves. Okay, and the speed of this sound is 340 meters second per minus 1 at normal temperature and pressure. Okay, at this condition, normal temperature and pressure, the speed of the sound is 340 meter per second. Okay, the velocity or the speed of sound is 340 meters second per minus 1. And here the speed of this light is 3 into 10 to the power 8 meters second per minus 1. 3 into 10 to the power 8 meters second per minus 1. These are the difference between the sound waves and light waves. Okay, what's the first point? It need a medium for its propagation, but light waves does not need the medium for its propagation, and it is a longitudinal wave. Sound waves are longitudinal waves and this light waves are transverse waves. Okay, transverse waves. And here the wavelength range 1.65 millimeter to 1.65 meter. Here it is 4 into 10 to the power minus 7 meter to 7 into 10 to the power minus 7 meter. And speed is about 340 meters second per minus 1 at normal temperature and pressure. This NTP, what is the full form? Normal temperature and pressure. And the speed of this light is 3 into 10 to the power 8 meters second per minus 1. Now we can mark some question answer. Roman letter 6, question number 1. What is a longitudinal wave? Okay, what is a longitudinal wave? Okay, it is not given in the book properly, so you have to write down this answer. here. Okay, the first question, it is a wave in which particles are vibrating along the direction of wave motion. Note it down. And to write it in a note or in the book itself you write it. Okay, it is a wave in which particles are vibrating along the direction of wave motion. Particles are vibrating along the direction of wave motion is called what type of wave? Longitudinal wave. Second question, what is the audible range of frequency? What is the audible range of frequency? It is given in page number 60. Page number 60, audible waves paragraph. These are the sound waves with a frequency ranging between 20 Hz and 20,000 Hz. These are generated by vibrating bodies such as vocal cords, stretched string, etc. Okay. Then the same Roman letter, question number 5. Name any 3 animals that detect the ultrasonic sound waves. Okay. So that is question number 5. Certain creatures like mosquitoes, dog, bats, dolphin can detect these waves. Okay. So this one question number 5. Now below that one question is there. You have to mark difference between the sound wave and light wave. What are the difference between sound wave and light waves? Okay, this 4 point is given. That one you can mark here. Okay, 4 points also mark it. And today your homework is Roman letter 6, question number 1, 2 and 5. Along with that, you have to learn this question, difference between sound waves and light waves. Okay, tabular column, very simple only. Okay, and the next one, categories of sound waves based on their frequencies. Okay, already first question you are learning, no, not first question, second question and the fifth question. From that sound categories only already you marked. Along with that one more paragraph also you have to learn. Okay. So categories of sound waves based on their frequency. 3 types of waves. Okay. So that one you have to learn and write. Okay. This all this you have to learn and write. Question number 1 to 5. Okay. Here 3 questions and this 2 questions. Okay. Learn and write in your note. And moreover, you have to read page number 59 and 60. Okay. So reading habit is very important. Okay. Then only you can attempt one word questions. So you have to read page number 59 and 60. Okay. Thank you, students.